Phases exist at equilibrium. Equilibrium just means you have two opposite things happening at the same time, or the same rate. And I'm going to put reactions in quotes because it doesn't necessarily have to be a chemical reaction. You could have the physical reaction of phase changes happening at the same rate. So we don't see these reactions happening or these changes happening because they're happening at the same rate. So if you think about a glass of ice water, the solid ice, and then you have liquid water. So if you go from liquid water and those molecules touch the cold ice cubes, they will freeze. But then you have the solid ice touching the warmer liquid, so the ice starts to melt. So you have freezing and melting actually happening at the same time, so you have some equilibrium. Eventually, over time though, all of the ice does melt because all of the ice would have enough energy to become a liquid. So a phase is another word for state, solid, liquid, and gas. At a phase change, you have equilibrium. You have two opposite changes occurring at the same time, at the same rate. So what are our different types of phase changes? You have solid to liquid, which is melting, and our example of that is going from ice to liquid water. Freezing, you have liquid water turning into ice. Sublimation, the example is dry ice, which is solid carbon dioxide turning into carbon dioxide gas. There's no liquid whatsoever, that's why it's called dry, and it's called ice because it looks like solid water. Liquid to gas, evaporation, so another way of saying that is to boil or to vaporize. Now, those three words actually have differences in their definition, but they're all talking about going from a liquid to a gas. If you provide the heat, then it's called boiling. If you are not applying heat to it, then it could be evaporation or vaporization. And water boiling is the example there. Gas to solid is called deposition. So you're taking, let's say, water as a gas, and it's automatically turning into water as a solid, which happens on extremely cold mornings. That's how frost is formed. Gas to liquid is called condensation. So you have your gas molecules in the air. They hit the cold can of soda that you have, and they turn into liquid water. Some people say that the can is sweating, but the water that's being formed on the outside of the cold can is from the water vapor in the air. If you are in a car during a rainstorm and you have the windows rolled up, the water molecules that you are breathing out hit the inside of your window and condense to form that foggy look in the window. Solid is the most ordered phase that we have. Gases, the molecules are becoming more spaced, so there's more space between the molecules. So we have a little bit more disorder or a little bit more random. When you go from a liquid to a gas, there's even more space being created between the molecules, so it's even more disordered or more random. So as you go from something ordered to disorder, you have to add in energies to make those molecules start really moving around, which is considered endothermic because you're adding in energy. Going from something that's disordered to ordered, you're removing the energy to slow them down so that they can get closer together and more ordered. So that is considered exothermic. So as you go from solid to liquid to gas, that's endothermic process because you have to add in energy to create that space or randomness. As you go from gas to liquid to solid, you're removing that energy to slow the molecules down, get them closer together, more ordered. So that is an exothermic process. So if we think about solid to liquid or melting, we would be becoming more disordered, so that is an endothermic reaction. Liquid to solid, you're becoming more ordered, you're decreasing the space between them, so that is exothermic. Solid to gas, you're creating lots of space, lots of disorder, so that is very endothermic. Liquid to gas, you're creating space more disordered, so that is endothermic. Gas to solid, you're going to really decrease the space between the molecules, really increase the order of them, so that is very exothermic. And then gas to liquid, again, you're decreasing the space, increasing the order, so that is exothermic as well.